Good morning, all of you. Good morning, all of you. In this session, I am going to explain about parallelogram law of forces on its problems. Before going to the problems, first you have to know about parallelogram law of forces statement. This is the statement for parallelogram law of forces. It states that if two coplanar concurrent forces acting at a point are represented in magnitude and direction by two adjacent sides of a parallelogram, then the diagonal passing through the point of intersection represents the resultant in both magnitude and direction. Okay, first, what is coplanar? If the line of action of all the forces lies in a single plane, then the force system is called coplanar force system. Okay. And concurrent forces. What is concurrent forces? If the line of action of all the forces lies in a single plane and meet together at a common point, then the force system is called coplanar concurrent forces system. Okay, so this is the example. So these two forces are acting at a common point, that means concurrent. Okay, and these two forces are lies in single plane, that is coplanar. Okay, here P and Q are the two forces. Alpha is the angle between two forces. Okay, then I want to determine the resultant of these two forces. Okay, for determining the resultant of these two forces, we can use so many methods. Okay, so parallelogram law of forces is the simplest method for determining the resultant of two forces. Okay, so this parallelogram law of forces is used to find out the resultant of two concurrent forces only. Okay, so this method is very simple and very important for exam point of view. Okay, so here I consider P is the horizontal force, Q is the inclined force. So alpha is the angle between P and Q forces. Okay, according to the parallelogram law of forces statement, okay, you have to consider a parallelogram for determining the resultant. Okay, now I am showing the procedure. First, I consider a force Q with an angle theta with respect to the x-axis, and then after I consider the given horizontal force is P. Okay, so this is the given diagram. Okay, now I consider a similar force P. Okay, so I consider same length, that means the same magnitude. Okay, here, so the magnitude of this force is equal to this force. Okay, and then after I consider this inclined force here. Okay, so this one and this one both are equal in magnitude and direction. Okay, here also angle between horizontal plane and force Q is also alpha. Now by joining these two corners, you can get the value of resultant. Okay, according to the statement, okay, this diagonal line indicates the resultant of the two forces. Okay, so from derivation, the magnitude of this resultant are equal to square root of P square plus Q square plus 2PQ cos alpha. This is the formula for determining the resultant of the two forces. Okay, now the tan theta theta is the direction of a resultant with respect to the x-axis. Okay, theta is the direction of a resultant with respect to the x-axis, with respect to the horizontal force, for example, or with respect to one force. Okay, so here tan theta equal to q sin alpha by p plus q cos alpha. Okay, so from this equation you can find out the value of theta. Theta equal to tan inverse of q sin alpha by p plus q cos alpha. Okay, so by using these two formulas, you can calculate resultant and direction of the resultant. Okay, so in next slide I will explain about problems using these formulas. Okay, this is the first problem. Two forces P and Q. Here P and Q are the two forces acting on a bolt at a point A as shown in figure. Determine the magnitude and direction of the resultant. Here you can observe P and Q are the two forces. These two forces are coplanar and concurrent forces. Okay, these two forces are acting at a common point A. Okay, so here the angle between horizontal plane and force P is 20 degrees, and the angle between force P and Q is 25 degrees. Okay, by using parallelogram law of forces, you have to find out the value of magnitude and direction of the resultant. Okay, so from the given this is the method one to determine the resultant. Okay, there is an alternate method also is there. I will explain. Given data is here P is the magnitude, P equal to 40 newtons, and Q is the magnitude of a second force, Q equal to 60 newtons, and angle between force P and Q equal to 25 degrees. Only you have to consider the angle between two forces. Okay, so don't consider 20 degrees. Okay, don't consider 20 degrees. Only you have to consider the angle between two forces, that is P and Q. Okay, here alpha equal to 25 degrees. That is the angle between two forces. Okay. Now, from parallelogram law of forces, already we know that the formula for magnitude of a resultant, that is R equal to square root of P square plus Q square plus 2TQ cos alpha. Substitute the values of P, Q, and alpha in this equation. You can get the value of magnitude of resultant. Okay, so finally R equal to 97.72 newtons. This is the magnitude of a resultant. Okay, magnitude of a resultant for these two forces. Okay, here alpha equal to 25 degrees. Okay, you have to consider only angle between two forces. Okay, now for determining the direction of the resultant, theta is the direction of a resultant with the force P. With the force P, now theta equal to tan inverse of Q sin alpha by P plus Q cos alpha. Okay, so this is the equation for determining the direction of the resultant. Now substitute values Q equal to 60 newtons and P equal to 40 newtons, alpha equal to 25 degrees. Okay, so tan inverse of 60 sin 25 degrees divided by 40 plus 60 cos 25 degrees. Okay, now from these values you can get the value of theta. Okay, theta equal to 15.04 degrees. Okay, so this angle indicates the direction of the resultant with respect to the force P. I will show the resultant. Now, from the previous calculations, we got resultant R equal to 97.7 newtons and resultant are equal to resultant are equal to 97.72 newtons, and angle theta is the direction of the resultant, theta equal to 15.04 degrees. Okay, this is the given diagram. Now I am showing the final diagram. Okay, so this is the bolt. Now I am drawing the force P equal to 40 newtons and Q equal to 60 newtons. Okay, these two are the given forces. P and Q are the two forces. Okay, now alpha is the angle between two forces. Alpha equal to 25 degrees. Alpha equal to 25 degrees. Okay, now the resultant R equal magnitude of resultant R equal to 97.72 newtons, like this. This is the resultant of these two forces. Okay, and the magnitude of this resultant equal to 97.72. Now theta is the direction or angle made by the resultant with respect to the force P. Okay, that is the theta. Okay, so this is the final diagram for this problem. Okay, now coming to the alternate method. Okay, so question is same, but I am using method of projections. Here for determining the magnitude of resultant, I am using method of projections. Okay, so here I consider x-axis and y-axis at the point A. Okay, now this is the given diagram. I want to convert this diagram into horizontal and vertical components. Okay, so here this is the given force P equal to 40 newtons, and the angle of or the direction of this force 40 newtons equal to 20 degrees, and this is the direction of the, so this is the force Q 60 newtons, and 45 degrees is the direction of the force 16 newtons with respect to the x-axis. Okay, so 20 plus 25 equal to 45 degrees. Okay, 45 degrees from the x-axis. Okay, so this is the given diagram. Now I want to convert this diagram into x and y components. So that's why you have to consider x and y axis. Now from given question, you can observe this 40 newtons lies in first quadrant. Okay, this 40 newtons and 16 newtons, these two are lies in first quadrant. So this is the given force F and angle theta. Then if you want to convert this inclined force into horizontal and vertical forces, then you have to use these equations. Okay, so this is the x-axis, that means x component. This is the y-axis, that means y component. Okay, so here F cos theta, here this is the adjacent side, this is the opposite side. Okay, so F cos theta. Now here 40 is the F, so F equal to 40 and cos theta equal to 20 degrees. So 40 cos 20 degrees is the x component, and y component is 40 sin 20 degrees. Okay, this is the answer for force 40 newtons. In similar way, for 60 newtons, this one also lies in first quadrant. So same procedure, 60 cos 45 degrees. Okay, here the angle is 45 degrees. So 60 cos 45 and 60 sin 45. Okay, so here I converted this diagram into this. Okay, these are the horizontal and vertical forces diagram. Now after drawing the forces diagram, you have to convert all these forces into tabular form. So 40 newtons. Yeah, this is the x-axis. That means x component. So 40 plus 40 cos 20. Okay, and this one is the y-axis. So y component plus 40 sin 20. For 60 newtons load, the angle is 45 degrees. Okay, this one is the x component, that is a plus 60 cos 45, and this one is y component plus 60 sin 45. Okay, now by adding these two equations, you can get the value of summation effects, sum of all horizontal forces. Okay, so the sum of all horizontal forces. Okay, these are the two horizontal forces. Okay, by adding these two forces, you can get the value of fx. Okay, now similar way, by adding these two vertical forces, you can get the value of fy. That is sum of all vertical forces along the y-axis. Okay, for determining the magnitude of resultant, you have to use this formula, r equal to square root of horizontal forces square plus vertical forces square. Okay, now finally we got the magnitude of a resultant r equal to 97.72 newtons. For determining the direction of the resultant, okay, this is the formula for determining the direction of the resultant. Theta equal to tan inverse of summation fy by summation fx, sum of all vertical forces divided by sum of all horizontal forces. Okay, now by using this equation, you can get the value of theta. Theta equal to 35.04 degrees with respect to x-axis. Theta x means direction of resultant with respect to x-axis. Okay, so this is the y-axis. Here the value of the sign for fy is positive. So you have to consider this vertical force in upward direction, and the value of horizontal force is positive. So you have to consider right side direction. For right side direction, you have to consider positive sign. For upward direction, you have to consider positive sign. Okay. Now these are the two forces. Now the resultant lies between these two forces. Okay. So this is the position of the resultant R, and the angle theta is the angle between horizontal force and resultant. Okay, so this is the alternate method. Okay, so in this method I used method of projections method. Okay, now coming to the second problem. Two forces P and Q are applied at a point A of a hook. Support as shown in figure, where P equals 60 newtons and Q equals 25 newtons. Determine magnitude of the resultant and direction of the resultant with respect to force P. Okay, so here two forces P and Q are acting at a common point A. Okay, these two forces are acting on a hook. Okay, so point A is the common point. So here the value of P equals 60 newtons and Q equal to 25 newtons. Okay, so here the angle between these two forces equal to 20 degrees plus 35 degrees. The total angle between these two forces equal to 20 degrees and 35 degrees. That is alpha equal to 55 degrees. So from given data, magnitude of a force P equals 60 newtons and Q equal to 25 newtons, and alpha equal to 55 degrees. Okay, alpha equal to 55 degrees. Now already we know from the parallelogram law of forces, already we know the formula for magnitude of the resultant, that is r equal to square root of p square plus q square plus 2pq cos alpha. So now you have to substitute the value of alpha equal to 20 plus 35 degrees. Okay, that is the total angle between two forces. Okay, Now from this equation, we can get the value of resultant or okay, magnitude of resultant equal to 77.1 Newton. Okay, this is the magnitude of these two forces. Now theta is the direction of the resultant with respect to the force P. Okay, now this is the formula for determining the direction of the resultant. Okay, here Q equal to 25 newtons and P equal to 60 newtons and alpha equal to 55 degrees. Okay, now the angle theta equal to 15.4 degrees. Okay, theta equal to 15.4 degrees. Now I am showing the final diagram. Okay, so this is the given hook. These two are the forces. Okay, these two forces are acting at a common point A. Okay, now R is the magnitude of the resultant. So this resultant lies between these two forces like this. Okay, from the parallelogram law of forces, the diagonal passing through the two corners is called resultant. Okay, so the magnitude of this resultant equals 77.1 and alpha is the total angle between two forces, where theta is the direction of the resultant with respect to the force P. So this is the force P. So theta equal to 10.4 degrees with respect to the force P. Okay, theta is the direction of the resultant with respect to the force P. Okay, this is the final answer for this problem. Now by using method of projections, we can also determine the resultant and direction. Okay, now this is the another problem. A boat is moved uniformly along a canal by two horses pulling with the forces P equal to 890 newtons and Q equal to 1068 newtons, acting under an angle alpha equal to 60 degrees. Okay, as shown in figure, determine the magnitude of the resultant pull on the boat and the angles beta and gamma. Here, this is the boat and this is the diagram. You have to assume this is a canal. Okay, so Q and P are with two horses. Okay, these two horses are pulling the boat in canal. Okay, the force applied here, force P equal to 890 newtons and force Q equal to 1068 newtons. Okay, here the total angle between these two forces P and Q is 60 degrees. Alpha is the total angle between two forces. Alpha equals 60 degrees. Now by using parallelogram law of forces, you have to find out the value of resultant and the direction of the resultant. Okay, now here this is the given data. Okay, P equal to 890, Q equal to 1068. Okay, from parallelogram law of forces, already we know the formula for resultant. Magnitude of resultant R equal to square root of P square plus Q square plus 2PQ cos alpha. Now here alpha equal to total angle, alpha equal to 60 degrees. So P equal to 890, Q equal to 1068. So substitute these values in this equation. Okay, you can get the value of resultant, magnitude of the resultant. So R is the resultant. Okay, R is the magnitude of the resultant, 1698 newtons. Okay. Now for determining the values for determining the angles gamma and beta, you have to find out the value of direction of the resultant. So already we know the formula for direction of the resultant. Theta equal to tan inverse of Q sin alpha by P plus Q cos alpha. So substitute the values of Q and P values. Okay, here alpha equal to 60 degrees. Okay, now from this equation you can get the value of direction theta. Okay, here theta means the angle between resultant and force P. Okay, direction of the resultant with force P. So here theta equal to gamma. Okay, so gamma equal to 33 degrees. Now the total angle between P and Q forces equal to 60. So from the equation, okay, alpha equal to beta plus gamma. Okay, alpha equal to beta plus gamma equal to 60 degrees. From the equation we can get the value of beta. Okay, beta equal to total angle alpha minus gamma. Already we know the value of gamma, that is 33 degrees. Gamma equal to 33 degrees and alpha equal to 60 degrees. Okay, so substitute alpha value and gamma value in this equation, you can get the value of beta. So beta is the angle between resultant and the force Q. Okay, now this is the answer for this problem. Okay, now another problem. A boat is moved uniformly along a canal by two horses pulling with forces P and Q, acting under an angle alpha equal to 60 degrees as shown in figure. To move a boat uniformly along a canal at a given speed requires a resultant force R equal to 1780. Okay, here the magnitude of resultant R is given, that is 1780 is the resultant of the boat. Okay, if the angles that the two ropes make with the axis of the canal are beta equal to 25 degrees, alpha gamma equal to 35 degrees. Okay, gamma equal to 35 degrees, beta equal to 25 degrees. Now alpha equal to gamma plus beta, that is 60 degrees. Okay, total angle between two forces equal 60 degrees, alpha equal to 60 degrees. From the question you have to find out the value of or the value of magnitude P and Q. Okay, here P and Q are the two forces acting on the boat. We don't know the values of P and Q. By using given data, you have to find out the value of magnitude P and magnitude Q. Okay, these two are the two pulling forces. From parallelogram law of forces, here the angle between two forces alpha equal to 60 degrees and theta. Here theta is the direction of the resultant. Here or direction of the resultant or angle between resultant and force P equal to gamma. Okay, gamma equal to 35 degrees. The value of gamma equal to 35 degrees is given. That means direction of the resultant theta. Okay, so here P and Q are the tensions in the ropes. Okay, so from the given question we have to find out the values of magnitude of P and Q. Okay, so from parallelogram law of forces already we know the formula for magnitude of a resultant R equals square root of P square plus Q square plus 2PQ cos alpha. From this equation, okay, you have to find out the values. Already we know that from given question the magnitude of the resultant R equal to 1780 is given. So substitute the value of R in this equation and substitute the value of alpha. Alpha is the angle between two forces. Okay, now finally you can get the equation 1. Okay, this is the equation 1. For determining the two unknowns, we need two equations. So this is the equation 1. Okay, now for second equation, I am considering direction of the resultant. Okay, already we know that gamma equal to 35 degrees, beta equal to 25 degrees, and alpha equal to 60 degrees. From given question, okay, already we know the formula for direction of the resultant. It is theta or gamma equal to tan theta equal to q sin alpha by p plus q cos alpha. Here already we know that theta equal to 35 degrees. So substitute the value of theta and alpha equal to 60 degrees. Okay. From the equation, okay, or cross multiply. Okay. So here we can observe P and Q both are unknowns. Okay, P and Q both are unknowns. So for determining the value of P or Q, first you have to resolve like this. Okay, so finally you got the equation 2, that is P, force P equal to 0.737 Q. This is the equation number 2. Okay, so from the equation 1, substitute the equation 2 in equation 1. Okay, this is the equation 1. Okay, substitute the value of equation 2 in equation 1. So here finally we got the value, that is a Q. Q is the magnitude of the upside force. Q equal to 1178.79 newtons is the magnitude of the force. Okay. From second equation, you can get the value of force P. Okay. So this is the second equation. P equals 0.737 Q. Substitute the value of Q. Q equal 1178.79 newtons in this second equation. You can get the value of force P. Okay, force P equal to 868.76 newtons is the second force. Okay, so this is the final answer. Okay, so here P and Q both are unknowns. Okay, P and Q are both are unknowns. So these two are the answers. Okay. Here in this question, resultant, magnitude of resultant is given. Okay. So this is the different problem and very important for exam point of view. Okay. In next class, we can discuss more problems on method of projections.